We're looking at this system that has a string and a block and a pulley, and it's frictionless, so it's nice. It's also in equilibrium. And we're trying to find the lowest frequency if we wanted to create a standing wave on this thing. And that would literally just be one loop, a single loop right here. It would be the lowest possible frequency, because f of n equals 1 will give us an equation kind of like n divided by 2L times the square root of the tension divided by the mu. Well, if n was just 1, then it would be the lowest possible frequency. So let's just go ahead and call that 1. And so then we're trying to figure out the rest of these things. The L is obviously going to be this h right here, so 0.53. And the mu is already given to us right here, so we can almost plug that in right here. So the only thing we have to find is going to be this tension. Now the tension is going to be coming from this object here. But let's see, the only thing we have on it right now is going to be our mg. It's going to be the gravity. And essentially, the component of the gravity that is along this line is going to be the tension, because here's your string right here. And the tension will be going this way on the string, but the idea is that the string tension, and I mean, it's just going to be the same thing as the component of this gravity, because this stuff has to equal out because it's in equilibrium. Now, in order to do this, we kind of need to set up a series of angles. So if we continue this little line down here, we're going to notice that this angle would be the same as that angle, so we can kind of make like a little triangle out of this. And since this would be 90 degrees right here, then we can actually calculate this angle. That would just be 90 minus the 32 right there. So I believe that would be 58 degrees right in here. 58 degrees. Well, that's nice, because now we have, like, you know, we have the hypotenuse right here, and we're trying to find the cosine of that 58, because we're trying to find the adjacent, which is this one, and we know this one is the hypotenuse. So the cosine of 58 is going to be equal to adjacent. That's going to be our tension force that's going this way. Divide that by the hypotenuse, which is just mg. So let's solve for our adjacent side. That's going to be the tension. So mg cosine of 58 equals the tension. So let's just plug that in there and see if we can use the calculator for that. So we're just going to go 1 divided by 2 times the 0.53, and then we're going to square root. The tension on top is going to be mg. That's 1.44 times 9.81 times the cosine of 58. And on the bottom side, we'll just put this thing. It's 0.00051. And so we should get a frequency of 114.3 hertz.